Autonomous technology can do a lot more than just remove an operator. It can enable us to rethink what's possible. Traditional aerial crop spraying, as one example, is highly efficient, but also very constrained.
So being able to fly at night, it can double the spray window per day. It could conceivably triple it. Oftentimes the conditions at night are much more favorable for spraying.
Pyka is a company that wants to make aviation safer, more affordable, and more accessible through automation and electrification. CEO Michael Norcia and the team think the best path to this future is in agriculture.
So when we started YC, we thought we were probably going to go into cargo. And then over the first month, we pivoted towards thinking agriculture was the way to go.
Since their time at Y-Combinator, Pyka has focused on the banana industry in Central America. Over the years, they've evolved their autonomous electric aerial spraying capabilities and now plan to expand their services into Brazil and beyond.
We'll be the only company in the large autonomous airplane world who's actually scaling a product, and by like a multi-year head start.
Autonomous electric fixed wing crop spraying with Michael Norcia of Pyka on today's Future of Agriculture podcast. Hello, fellow ag nerd. Thanks so much for joining me for another episode of the Future of Agriculture. My name is Tim Hamrich, and every week you and I get to hear from the founders, farmers, innovators, and investors shaping the future of the ag industry. And before we dive into today's episode, I want to take just a moment to thank our quarterly presenting sponsor for this quarter, which is Acres. Name a place, a single source where you can find land for sale, comparable sales, and easy-to-use maps. Can't do it? That's where Acres comes in. This land analysis and mapping platform brings together the data you need to make confident decisions about buying, selling, or investing in a piece of land. That includes manually vetted comparable sales, soil data, crop history, elevation, flood insights, and more. There's no paywall. You can create an account for free today at acres.co and access 10 plus layers of data along with land listings, tools for saving and customizing maps, and PDF report generation. If you're in the land business and need more than just the basics, check out their premium and enterprise plans for features that support efficient due diligence, portfolio management, and fast valuations. It's all part of Acres' mission to make the land marketplace transparent and easy to access for anyone. Check out a parcel anywhere in the U.S. for free at acres.co. That's acres.co. Thank you very much to Acres for supporting the Future of Agriculture podcast. All right, now back to today's episode with Michael Norcia of Pyka. This is really a fascinating interview that not only features some pretty mind-blowing technology, but also a great example of finding product market fit, overcoming regulatory hurdles, and taking a futuristic idea and somehow converting that into a real business that solves real problems in the present day. For those of you who are entrepreneurial, I think you'll really be inspired by Michael's story, and you'll probably also enjoy some of the questions I ask him about his Y-Combinator experience that will take place later in the episode. Michael Norcia is the CEO of Pyka, which, as I mentioned earlier, is an autonomous electric aircraft company. Michael has a deep technical background in autonomous flight, having contributed to a wide variety of manned and unmanned electric aviation projects at Joby, Cora, and Kittyhawk. In 2017, Michael co-founded Pyka with the goal of combining two of his lifelong passions, which is electric aviation and business. I'm going to drop into the conversation here where Michael is talking about that passion for aviation and those early days of Pyka.
In many ways, I felt like I was born to do things in aviation. But really the impetus to start Pyka was through my work at these air taxi companies. Basically, my passion for aviation went from being a hobby to just getting introduced to the idea of like how powerful automating and electrifying flight could be. And so these companies, their vision is to build eVTOL air taxis so that we could all fly around in, flying car-like things one day. And, kind of the mentality of those companies was like, how do we make just an astronomically large impact on the world through aviation? And that was a cool, I think, line of reasoning. And that's kind of what led to Pyka, was trying to figure out a more practical approach to having an astronomically large impact on the world through aviation than going straight for an air taxi.
Yeah, no, I can totally relate to that because that comes up a lot on the show here. Is like, okay, what do we see as this crazy vision for the future, but also like what's step one toward that end as well? And it sounds like you kind of saw both of those things.
Yeah, exactly. And I think aviation, more than almost any other technology, like really requires a stepwise approach to innovation. Just the level of risk is so high, relatively speaking, just compared to other missions. And so you kind of can't enter, for example, the passenger carrying aviation world without a really deep base of understanding of the technology that you're introducing, just because of how risky it is.
And was agriculture, in your sights when you started Pyka? And what was it about agriculture that caught your attention?
Yeah, so basically, in the first 6 months of starting the company, we went through a startup incubator called Y-Combinator. And they really gave us just like extremely strong advice, which was to try and find the fastest possible way to market with our technology. And so at the time when we entered Y Combinator, we didn't know what use case we were going to explore. We knew we wanted to build autonomous electric aircraft, but we weren't sure if it was going to be for cargo missions or crop spraying or what. And so it was kind of the combination of that advice and then actually inviting the head of the New Zealand CAA to my parents' backyard for a meeting. Basically, we told them, we're building this big UAV, 400-pound electric thing. What could we get approval for in New Zealand? And his feedback was just like, crop spraying, that is the only thing. If you want to do cargo, it might be 2 years till we're comfortable with that. It might be 5 years. It might even be 10 years. So that was kind of the first thing that drove us towards ag, was just the regulatory reality, where it was, with big unmanned aircraft, one of the hardest things to do is fly it beyond the visual line of sight of anyone involved in the operation. It sounds silly, but the risk of your aircraft hitting another vehicle is actually one of the most difficult risks to totally mitigate. So anyways, crop spraying kind of skirts around that risk in a nice way. So that was the first thing that drew us to it. The second thing that drew us to it was really simple. It was just watching YouTube videos of mostly helicopters doing crop spraying. And, a common helicopter people use is the Jet Ranger, which is kind of a entry-level executive helicopter. It's about a little over $1 million, big turbine engine in it. And that was crazy to see this $1 million executive helicopter flying low over crops, spraying them. Basically, like, it's to first order, that job can be done with a big model airplane. So, that was kind of the gut reaction. It's like, okay, we could probably get regulatory approval for this. The way it's currently being done is insane. The thing that gave us pause was the fact that the mission is so dynamic and changing. Like, in a lot of areas of the world, you only spray a specific field once per season. And that's a really difficult thing to deal with from an automation perspective. Like, an ever-changing environment is the most difficult challenge. So we were worried about that. I think we've got a really good way to de-risk it in the near term and kind of build up the sophistication of the autonomy and introduce that challenge progressively.
Well, could you talk more about that? Yeah, how have you sort of de-risked that part of it, the dynamic nature of it?
Yeah, very simple. So basically starting in the banana growing regions of the world. So bananas are an unusual crop. They're sprayed year round. So 50 sprays per year. And so that really helps with that issue. We have to map out a plantation once, and then we're able to amortize all of the time, sort of, mapping it out, doing risk assessments, et cetera, over the next 50 sprays. So yeah, simple solution to a very complicated problem.
And who's flying these? Are they Pyka employees that are flying them, or how does that part work? Could you maybe walk us through the experience of needing to, to spray a banana farm?
Yeah, so we're exploring two different business models. Basically a hybrid approach where in certain geographies, we're very much involved in the operation. And then in other geographies, the customer, who is currently a company that flies typically air tractors, is flying the product for us.
Did it basically come down to like, hey, they need a spray application so often that they're feeling this pain more than, other crops? Is that why, you started with bananas, or is there more to it than that?
Yeah, that's exactly right. So the demand from the customer is acute with banana growers. Just it's such a huge part of their industry. Crop spraying it's a big part of growing anything, but bananas, it's like a quarter of the whole operation is dealing with the chemical applications. Maybe that's not quite true, but close. So that was a really important element to it. The other one too is the regulatory aspects of these aircraft are phenomenally daunting. It's unlike anything you see in ground-based vehicles, and so it's really important for us to have basically like backing from the government to try and help push these programs through. So the banana growing regions of the world, a single banana producer might represent 1% to 2% of the country's GDP. And so that's very helpful in terms of just like getting the attention of a regulator and getting their buy-in to test a new technology. Because the tricky thing with aviation regulators is, they're just human beings like us who have jobs. They don't really want to take a big risk on something. There isn't like a whole lot of vested interest in them and in saying, okay, sure, yeah, fly this, enormous UAV in our country for the first time. And so we need some way to kind of get that interest and get the regulator comfortable with the idea of doing something new.
Right. And in order to get that, what is the value proposition that you're bringing to the grower partner, collaborator, whatever you want to call it in this case? A lot of times I think we want to jump to the conclusion that, labor savings, and maybe that's part of it. But what I found is usually it's more than that. So what is the value proposition that you bring to them?
Yeah, good question. Labor actually is not on the list. There's kind of like 5-ish key value propositions. So starting, we can fly at night. That's a really, really tantalizing proposition. A lot of the sort of viable spray window in Latin America and really most of the world is like 3 hours in the morning and maybe 1 hour in the evening. So you've got 4 hours per day to utilize your spray equipment to get the job done. You can stretch that window, but the conditions start to get really just not suitable for the application. You start losing a lot of your chemical, which is really not wise from a just budget perspective. So being able to fly at night, it can double the spray window per day. It could conceivably triple it. Oftentimes the conditions at night are much more favorable for spraying. Not always, it depends on, the local sort of environment. So that's a big one. We've done a lot to try and mitigate the risk of off-target chemical drift. So the aircraft has a dynamic wind model that runs on the vehicle and it updates 100 times per second. We're able to use that wind model to stop spraying when the conditions aren't suitable. In the not too distant future, we'll use that wind model to dynamically adjust the way that we spray. So change the turn on and turn off times, shift our spray runs left and right in order to really target the spray. That's a big one. We also want to try and do stuff relating to inversions eventually and automatically detect those in order to stop spraying if there's any sort of semblance of an inversion. The plane's really quiet, which is also helpful for flying at night. Just the whole spraying activity can be a lot less kind of in your face than it otherwise would be. And that's definitely relevant for a grower who has to spray once per week year round. Obviously, there's no human being in the aircraft, which is a huge, huge win. We really see that as like a powerful value proposition for customers who fly a lot of aircraft. For a mom and pop air tractor flying, shop, like it's more or less a labor of love. And so getting the pilot out of the aircraft is not attractive. But for people who are trying to run scaled aerial application companies, hiring pilots is really, really difficult. You have to pay them an astronomical amount of money to keep them. It's a lot like Alaskan crab fishing, where you're paying someone a huge amount of money for a seasonal job where there's a very real chance of them dying by the end of it. And I think just the appetite for that style of that profession is like dwindling with, maybe my generation or Gen Z or whatever. So, and then cost. Cost is the last one. We can very easily compete on cost. We typically don't really. The other value propositions are strong enough to support more or less a kind of like cost parity per acre.
And when you say cost, do you mean the cost of the spray plane versus a traditional kind of crop dusting plane, or kind of the cost of spray to acre, or both?
The cost of sprayed acre, yeah. So we don't sell the planes at this point, we lease them. And so just comparing the kind of per acre sprayed vehicle associated costs with our technology versus an air tractor, we could make it dramatically less expensive, but we take up most of that savings with the lease. But typically the lease terms are set so that it's, 20% less expensive per acre sprayed than running an air tractor.
And what needs to happen first? A recharge of the battery or a refill of the tank?
A refill of the tank. So the aircraft is currently designed to do 2 spray missions per battery swap.
And compare that with a traditional crop duster. How much is a Pelican sprayer? Acres per, I don't know how you want to put it, hectares per hour. I'm not sure what the metric is, but kind of compare the two.
Yep. So a Pelican is about half of the productivity of an air tractor. There's obviously different air tractors, but of a 602, something like that. So about, ballpark 120 acres an hour. Air tractor is maybe 250. It depends on the water rate and, various other factors.
And what's the operator doing while it's spraying? Is the operator watching it? Can the operator monitor multiple at once? Is there a need for an operator at all? How does that work?
Right now, it's a 1-to-1 operator to aircraft ratio. So the operator is monitoring a laptop that has a bunch of telemetry coming back from the aircraft. They basically issue high-level commands so they can tell the airplane to stop spraying and loiter. They can tell it to come back and land, that kind of thing. In very unusual emergency situations, they can actually take over and maneuver the aircraft kind of manually, but it's in a really dumbed down version of flight where you can't really mess it up. So by and large, it's issuing high-level commands and then mission planning when the airplane's actually back on the ground, setting, the spray polygons, keep out zones where you don't want to fly if there's, like a school nearby, something like that, entering certain obstacles like power lines, etc.
Mm-hmm. Whenever I think of drone, I think of like the quadcopter type drones and not the fixed wing. We have interviewed other drone spraying companies on the podcast before, Rantizo, Precision AI. Those might be the only two. What is the advantage in this fixed wing drone over like the copter drones?
Yeah, so our view on this is basically fixed wing technology is really good for broad acre spraying. And then multi-rotor drones are very good for small acreage and very leafy foliage, very leafy canopies, so orchard and vineyard spraying. And the reasons for that are twofold. So first, the way that the chemical is delivered is very different between the two planes. Multi-rotor puts the chemical in the downwash of the propellers, so it's basically like an air blast of chemical. So that's good if you're shooting down onto a leafy canopy. It's really not great if you're doing broad acre. And the reason for that is as you start to fly fairly fast, the multi-rotor basically has this large entrained vortex around it. And so you get this like vortex of chemical swirling around the actual drone, which is just not good from a sort of chemical efficacy perspective, from a drift perspective. Whereas, fixed wing aircraft, not great for spraying an orchard, like you don't get good penetration down into the canopy. Really good for broad acre because it's just this nice clean sheet of chemical going down. So that's one big difference. And then the other big difference is just sort of the physics of scaling it up to a big vehicle. So kind of regardless of the size of the vehicle, a fixed wing aircraft takes about a third of the capital to move a gallon a mile. So it's a much more efficient way to sort of transport large quantities of chemical around. And then it also lends itself really well to sort of centralized operations where you have an aircraft that is a fixed base that can then ferry out 4 miles and service an entire territory around it. Multi-rotor can't do that. You have to drive it to each plot and set it up, spray that plot. And so it just gets tricky to kind of build that technology into an elegant solution to spray 2,000 acres a day, for example.
This is a simple question with probably a much more complicated answer, but maybe you could dumb it down for me here. How do you decide how big your aircraft should be? How do you arrive at the optimal size?
That's a good question. So you kind of need to look for constraints in some way. And so one of the constraints that we found, or two of them, the first was that there's kind of a regulatory cliff around 1,320 pounds. If a plane is less than 1,320 pounds, it's regulated one way and it's pretty relaxed. If it's over, it's regulated a different way. And that's from the passenger carrying world, but we figured there was a good chance that some of that would transfer down into the big commercial drone world, and it has. The other one is that we wanted the aircraft to be trailerable and really easy to maneuver around and assemble with two people without any ground support equipment. And so that also kind of led to this 1,320 pounds. It works nicely. Like the plane fits really, really nicely on a small flatbed. I mean, it's not that small, but it's not oversized. It's not over width. You can pick up one of the wing sections with two people. You know, it's about 55 pounds. The batteries aren't too unwieldy. You can taxi it around by just pushing on the airplane. So those are a lot of the factors. It's a great size. It's a really good size to sort of start with. It's a really good size for the high intensity spraying that we're currently focused on. For a lot of the work that we want to eventually do in the United States and some of the work that we want to do in Brazil, there's definitely going to be a benefit to having a bigger plane. So I wouldn't be shocked if in 5 years we'll be flying something that's close to an Air Tractor 402. So, you know, more like a 4,000 pound aircraft here in the States.
Cool. And talk about that trajectory. So are you currently still only in bananas, and kind of what comes next in terms of the business growth?
We're currently in bananas and in Brazil, doing a variety of crops in Brazil. The Brazilian side is less far along than the banana side, but I suspect is going to start to really ramp up quite rapidly over the course of this year. So that's our kind of like our trajectory is basically bananas first, Brazil second, United States and the rest of the world third.
And what's taking you to Brazil? Obviously, I mean, it's a big ag country, but you know, what specifically is making that be the next step?
Yeah, it's arguably the largest market for us in terms of potential leasing revenue from our product. It's really like neck and neck with the United States. The other element is just there's some really exciting partners in Brazil. So Embraer is one of them. We've announced a little bit of our work with Embraer, but in a way we haven't announced everything. So yeah, just some really strong allies who believe in the technology, who are excited to see it grow domestically.
Right. And are you, in most cases, both in bananas and how you see things going in Brazil, are you taking the place of, you know, a traditional crop duster, or in some cases, is it making more sense to do this than an actual, you know, spray rig that would be driven, a ground-based spray rig?
Yeah, it's both. So in the banana growing regions, all the banana spraying basically is done by air. Just, I mean, it makes sense. You can't get a ground rig into a banana plantation. In other parts of the world, it's a much more complex dynamic. There's definitely an opportunity to eat into the ground rig market. In some cases, a very, very large opportunity to eat into the ground rig market.
And what's presenting that opportunity? Which part of the value proposition is kind of presenting that opportunity? Is it like weather based? You know, you don't have to, you don't get stuck in the mud, or you don't prohibited from going out there because it's muddy, or is it something else?
So it's actually can be cheaper to spray by air in certain parts of the world than running a ground rig. That's kind of the big forcing function. If you can do it at a lower cost. There obviously are a whole bunch of challenges associated with ground rigs, compaction, not being able to access the field, etc. So those play into the economic decision as well.
And did you all have to engineer your own spray system, or were you able to use kind of off the shelf, you know, technology for that?
We've engineered everything about it, actually. So if we had gone with an off the shelf system, it would have been 200 pounds and I think close to $70,000. And, you know, for reference, our airplane weighs 1,320 pounds and has a 700 pound payload. So if we had to give up 200 of that to the spray system, that would have been very, very sad. So yeah, we did it all ourselves. It's really quite a nice system. It uses a lot of high performance materials, a lot of carbon fiber, a lot of composites. It's got a really cool little spray pump that's super powerful and small. It's kind of like similar to a rocket engine fuel pump. So yeah, it's been a lot of work. We've had many things leak over the last 5 years. I can say that. So, but you know, is well worth it given what options were out there.
Right. What about battery technology? Is that improving to where you think, you know, you'll be able to drastically improve the performance of this in the foreseeable future?
Yeah, it's really improving. Mostly on cost. So over the last decade, the price of batteries per kilowatt hour has dropped by a shocking amount. I don't know, factor of 5, something like that. Mostly in the automotive world. So, I mean, it's entirely driven by the automotive sort of sector. What's really exciting for us is that it looks like we'll probably be able to use automotive cells in the spray plane for the first time starting this year. And so what that means is that the price of our batteries per kilowatt hour is going to drop by about a factor of 3 this year compared to last, which is cool. The cost of the batteries of these vehicles is about a third of the cost of building the entire airplane. So being able to have that just, fall by a factor of 3 is pretty phenomenal. Energy density is also improving at nowhere near the same clip, maybe 20% improvement over the last 10 years. That's exciting. I mean, there's no sign that that's going to end. So, right now we do 2 fills per battery swap. Maybe in 3 years, we'll be doing 3 fills per swap, or we'll have increased the tank, from a 700-pound payload to 780. But we'll see.
You've mentioned the regulatory hurdles with this being understandably, a significant part of it. Is that kind of the biggest unlock to growth for you right now, is kind of getting through those regulatory hurdles, or is it something else?
It's a little bit of the regulatory side, though. I think we've made really good progress on that. We have a pretty diversified business in terms of where we're operating. So we're in Honduras, Costa Rica, and Brazil, and we'll probably be in a 4th Latin American country before year's end. I think the most difficult thing, though, is really just getting the system to the point where it's reliable enough to be a good product to start to scale with. It's this interesting balance as a tech company developing a really complex vehicle product where you want to scale and you want to grow. But then on the flip side, there's a whole bunch of things that you still want to improve about the product. And it gets hard to improve your product when you have, 24 of them out in the field. Just making a minor change starts to become this large, logistics task. And so that's really what our main focus is on this year, is just logging a lot of flight hours in really representative environments so that we can, just crank through. Realistically, it's probably going to be 100 design changes before the end of the year, just improving the product's uptime, et cetera. Because the bar is really high. The air tractor very, very consistently does a, decent job of crop spraying. We need to very consistently do a phenomenal job of it. Right now, we inconsistently do a phenomenal job. So.
Did you have any concern about going to countries in Central South America, being from the U.S. and not knowing necessarily the political climate and the, all of those things? Or were you just able to mitigate those risks based on the partners that you were going into the country with?
It was really exciting the first times we went to Latin America. We talked to potentially very large customer, kind of at our first meeting in Costa Rica. And then we actually went with that customer to talk to 4 other relevant parties, including the regulator, over the course of the next 4 days. And we were just pitching everyone on what we wanted to do. The feedback was resoundingly positive. So no, it wasn't intimidating. It was really just this clear moment of product market fit. If anything, it was just exciting. It was just sort of sad that we hadn't found the market sooner, honestly, in the company's history.
Yeah, you mentioned Y-Combinator as if it was just another accelerator, but as I think a lot of listeners know, it's the most sought after accelerator probably in the world, would be my guess. How did you get in, not knowing what market you were pursuing or even really what your product was going to look like? What do you think got you in the door there, and what was the benefit of that program?
Yeah, good question. So we basically quit our jobs and bootstrapped the company for the first 3 months before we applied to Y-Combinator. So we had very little money. What we decided we wanted to do was build a subscale aircraft and fly it running our own software. So basically just a tech demo. The founding team is 4 co-founders. 3 of us are on the technical side. And it's a very stacked founding team from a technology perspective. And so we wanted to basically show YC that, or Y-Combinator. So we brought this big foam airplane to the actual interview. We were very, very nervous. The interview was 5 minutes long. It was basically Sam Altman, who is now the CEO of OpenAI, or something like that anyways, just like rapid fire aviation questions, mostly directed at me. Um, so, I mean, they take a lot of companies, the batches are 160 or 180 people. I don't know exactly what the process is for accepting founders, but a lot of it is really based on who the founders are and what YC thinks they're going to bring to the table rather than the actual idea. Because I think, I don't know, maybe like 30% of YC companies pivot their idea in the 3-month program itself.
And was it within those 3 months that you kind of, honed in on this agricultural opportunity?
Yeah, exactly. So when we started YC, we thought we were probably going to go into cargo. And then over the first month, we pivoted towards thinking agriculture was the way to go. We talked to 100 different aerial applicators in California, kind of during that pivot to try and just get their feedback on the idea. We also flew out to New Zealand to visit the regulator there and visit a number of the local aerial applicators as well. So yeah, in that 3-month period, basically, we totally changed the idea. We were building an airplane though. We wanted to do a kind of another tech demo over the course of that 3 months. So we ended up building this big 400-pound UAV that kind of looks more like a cargo plane, but it was a good foundation for all the crop spraying work that we're going to then do years later.
Yeah. Well, you said you interviewed aerial applicators, and in my experience, when you're asking someone about their feedback on a product that could potentially replace them, they tend to voice some objections as to why this probably wouldn't work. So I'm curious what you heard from them and what caused you to think like, okay, we should still kind of keep persisting with this.
Good question. So I actually didn't do the calls. It was 2 of the other co-founders who did them. But my understanding is that about a quarter of the aerial applicators were generally on board with the idea. They thought that automation in their industry made sense. I think maybe half of the aerial applicators were like agitated by the fact that they were receiving the call, and to varying degrees. Some of them would, like cuss one of our co-founders out and hang up the phone. And then the other quarter thought that it wasn't technically possible, that automating their job was simply unrealistic, basically.
Yeah, I think we all kind of think that, it's like, oh, well, yeah, I can see where automation is going to take jobs, but not my job. Obviously, not all of us are correct in that. Well, as you look back, what year did you graduate from YC, and what, as you look back, do you think has been the most valuable part of that experience?
So I think we were in the 2018 batch or 2017. I can't quite remember. The most valuable experience, I mean, it really was just directing us towards that like ruthless pragmatism around launching the product, just trying to find the lowest barrier to entry customer. They talk about this anecdote of looking for a customer who's like someone in the desert with no water. That is what we've done. And I'm very grateful for that. A lot of companies in the aviation world have tried to go straight for the sort of glorious end use case of like passenger carrying vehicles. And they've made, effectively zero progress on actual like revenue or commercial traction. So yeah, they sent us off on the right foot and in the right direction, which is so cool.
Cool. Well, so partially what started this was this guy from New Zealand saying, hey, go into ag, and you went into ag. Is he like, hey, how come you're not here in New Zealand yet?
Hey, I haven't spoken with him in a while. We went to New Zealand. So that was the first market that we launched our product in. So yeah, after Y-Combinator, we built our first crop spraying product, which we called the Egret. We built 5 of them. We sent 2 of them to New Zealand. The founding team basically moved to New Zealand for 3 months. We certified the product there. We did our first commercial sprays with a just wonderful farmer down on the South Island of New Zealand. Learned a ton from that. The exciting things are that we learned that it worked. We were able to do a really good job of spraying, even at, our 3rd chemical spray as a company. We also learned all sorts of things that didn't work. The aircraft was too small. The batteries overheated. The tail dragger landing gear was continuously a pain. Yeah, so that was exciting. We aren't operating in New Zealand anymore, unfortunately, but I would love to go back someday and bring a Pelican to the farmer we were working with.
Very cool. Man, and so as you kind of enter Brazil and like you said, make sure you're providing a phenomenal experience every time with consistency, what's kind of next for the company? I know you guys have raised a Series A. What are the next milestones you're looking to hit, and what's your focus right now?
Yeah, our main focus is just getting repeat orders with the launch customers that we're already working with. It's really clear what we need to do. We just need to basically crank through trials with them. I'm guessing sometime in the next 6 to 9 months is when we're going to start getting those repeat orders. And then the company enters a new phase where we're really like at that scaling moment. There's probably going to be a little bit more capital required to pull that off. Definitely a bit more sort of partnership development, for example, in Brazil. But very, very excited to be at that point. We'll be the only company in the large autonomous airplane world who's actually scaling a product, and by like a multi-year head start.
That's cool. Well, assuming you continue your success and Pyka is, wildly successful in the future, how does the future of agriculture look different because, of this available solution?
Yeah. This is like the thing I'm kind of most excited for is just being able to drive out in farmland in California or many parts of the world and just look out the window and see an aircraft flying itself spraying a crop. Just having that be a normal occurrence. And we are like absolutely going to get there. And that's really cool. Like that's like sci-fi stuff. It's a consistent theme in sci-fi actually is crops being sprayed by a robot. So it makes sense. It's not easy technically. It's not easy regulatorily, but it just makes logical sense to do the mission that way. So that's what I'm excited for in terms of what it means for growers. I think aerial application will become far more ubiquitous and available. The notion that it is a lower quality spray than a ground rig will evaporate. I think for many applications, it will be viewed as the sort of most economical and least harmful means of doing pest control. And then for parts of the world that have really intense spray activity, our goal is that the communities that surround those fields, those plantations, view the health risk associated with aerial application as being really much, much smaller than it used to be. So it's a lot of good things. I mean, we aren't saving the world or anything, but it's going to have a meaningful impact on agriculture and the communities that surround it, that's for sure.
Well, that's going to do it for today's episode. Thank you so much to Michael Norcia for being on the show. Go learn more about them at www.flypyka.com. That's Pyka in the show notes as always. We didn't get a chance to talk about it there on the episode, but they've also built a cargo derivative of the spray plane that Michael says has the capacity of 400 pounds of cargo, which can fly up to 200 miles. And they're looking for the right partners for the best fit for that plane as well. And they have big ambitions of someday bringing a passenger-carrying autonomous aircraft to the market. Oh, and they are hiring as well, especially for mechanical engineers, operations folks, software engineers, and more. You can learn more about those opportunities and explore them at that website, flypyka.com. Thanks again to Acres for sponsoring this quarter of the podcast. Try them out for free at acres.co. And thank you for your time and your attention. I don't take it lightly. I'll be back next week with another story of ag innovation.